All right, our next type of reaction is called single displacement reaction or single replacement. I've seen it said both ways. The who gets the data to dance part, will come to that in a moment. All right, so in a single displacement reaction, it's when an element reacts with a compound, and so the element somehow displaces part of the compound and they switch places. So A comes along and it's going to kick B out and take B's place, and then B's by itself. Okay, so it's always going to be an element plus a compound. That's how we identify these on both sides. All right, so just like we did, combination has one product, decomposition has one reactant. This is how we identify these: an element plus a compound. All right, so the products for these, once again, are predicted by ionic charges, and we use that to figure out the products. Okay, the element will always displace its corresponding part in the compound. A metal will always replace a metal. Okay, so you're not going to get the calcium coming along and kicking out the chlorine to go with the magnesium, because they're both positively charged, and what do positive charges do? They repel each other. That compound would never be formed. Okay, so the metal comes along, it's going to kick out the metal and go with the non-metal, and the metal's kicked off by itself. If I had a non-metal element and it comes in, it's going to replace the non-metal, and it's going to partner with the metal. Okay, and so it's always going to be that. Like is going to replace like, and that's always how it works. Okay, so now we need to decide, okay, what's going on? Does that always happen? No. Single displacement reactions are different in that they do not always occur. Sometimes there's what we call no reaction. We have to use what's called an activity series, and that's this thing. You have it in your workbook. Okay, this is a list of the different element metals specifically, and how they behave and what they do in terms of these type of reactions. What we call most active at the top, least active at the bottom. All right, so here's how we use it. The element trying to do the displacing must be higher or more active in order for the reaction to occur. So for example, if I have calcium and I put it in a solution of calcium sulfate, calcium is higher than the copper, and so it's going to kick out the copper, and the copper is going to be by itself. And now the calcium's with the sulfate. Okay, the way I like to think about this is like at a dance. Okay, we don't do cutting in much anymore, but think of an old style dance. You know, if some shrimpy little kid is dancing with a girl, and the big football player comes up and says, "May I cut in?" The likelihood of that little shrimpy kid being able to say, "No, you can't," to the big football player is unlikely. And so the bigger, more active element's going to kick in and kick the shrimp to the curb to sit on the chairs on the side of the gym while he dances with the pretty girl. It's a little rude, I know, but that's still kind of the best illustration I have in my mind. That, in contrast, if the football player is dancing with the girl and the shrimp comes back up and says, "May I cut in?" the answer is going to be no, because he's lower on the activity series. If copper tries to come back and cut in, it's not going to happen. Calcium's like, "Nope, already here, buddy. Move on." And so that would be a no reaction going that way. Okay, so if it's higher on the list, it will replace lower on the list. If it's lower, it's going to be no reaction. It's just not going to happen. Okay, so using that activity series, we can predict some products. So we've got aluminum trying to cut in with copper. So we find aluminum on our list right here. We find copper on our list down here. Aluminum is higher than copper, so this reaction will occur. And once again, the products are based on ionic charge. Aluminum is 3 plus, chloride's 1 minus, so the formula is AlCl3. Okay, notice the quantities changed because it's based on ionic charge. And then the coppers get knocked out by themselves, and then we add the coefficients to balance it out. Okay, now copper and iron. So once again, we find our elements that we have in mind. Here's copper, here's iron. Copper is lower than iron this reaction will not occur. And so you would write no reaction, or usually NO and then RXN for a reaction. That's the abbreviation for reaction. Okay. And then finally, magnesium, and this is a sulfuric acid, but we're trying to replace the hydrogen. So we've got magnesium, and then hydrogen's down here. So the magnesium will replace the hydrogen, and we will get that based on ionic charges once again for your formulas. Okay. All right. So that's with metals. With nonmetals, that's going to only occur with halogens. And the activity series for the halogens is the way in which they are written on the periodic table. That fluorine is the highest and iodine is the lowest. Okay. So you got to be higher in the periodic table to replace the other. So chlorine's higher than iodine. So the reaction occurs and they switch places. So the chlorine goes with the magnesium, the iodine's kicked out. And then here, same thing. Iodine's trying to replace fluorine, but iodine's lower on the list than fluorine, so there is no reaction. Alright, so let's run through some more examples of these. Zinc and lead 4 chloride. So take a moment, and first thing I like to do is just see if the reaction occurs. So zinc and lead, zinc, lead. That reaction will happen. Here, chlorine's higher than bromine on the periodic table, so that will occur. Magnesium and hydrogen, we just did that. That will occur. Gold and silver. Here's gold, here's silver. Gold's lower. So this one's going to be my no reaction. So the other three, I need to figure out what the products are. Once again, using ionic charges. Zinc is 2+. It's in that V. So it's 2+. Gives me ZnCl2. The lead gets kicked out. Chlorine and bromine replace exactly the same. Their charges are the same. And then magnesium and carbonate. And then no reaction there. Okay. So that's single displacement reactions. You use the activity series. If the element is higher on the list, the reaction occurs. Use your ionic charges to figure it out. You also identify this reaction because it's an element plus a compound. And so that's how we identify it. Then we'll move on to its cousin double displacement reaction in the next lesson.